Alright guys, our lesson today is that the student will be able to graph rotations. Alright, some of the vocabulary that we'll be using today. First, we have a rotation. It's a transformation that turns a figure about a fixed point. For all of the rotations today, that fixed point will be the origin with a location of 0, 0. The center of rotation is the fixed point about which a figure is turned, and once again we'll be using the origin as our center of rotation. The angle of rotation is the number of degrees that a figure rotates. Okay, let's take a look at our first example. We're asked to take this figure and we want to rotate this figure, triangle ABC, 90 degrees clockwise about the origin. What are the coordinates of A prime, B prime, C prime? Alright? Well, let's see what that looks like. Okay? Alright, so we're going to take our triangle and we're going to rotate our triangle, right, about the axis, the origin. So a 90 degrees clockwise rotation about the origin means we would be taking our figure and rotating it this way, so that the x-axis now becomes the y-axis and the y-axis becomes the x-axis. Right? We want to then look at the locations of our original points. So if I start with, let's say, A prime, or the new location of A, or the image of A, is located at positive 2, negative 2. 2, comma, negative 2. So after a 90 degrees clockwise rotation, point A is located at 2 and negative 2. Point B is located at positive 2, negative 1, 2, 3, 4, 5, 6, 7, 8. So positive 2, comma, negative 8 is the location of the image point B, which we'll call B prime. C prime is the location of the image of C, which is located 1, 2, 3, 4, 5 in the x direction, 1, 2, negative 3 in the y direction. So 5, comma, negative 3 would be the location of C prime. Right? Once we have the ordered pairs for our image, right, we want to then graph the rotation. Right? So I'm going to put this figure back since we were able to find our points, and let's graph our rotation after a 90 degrees clockwise rotation using the origin as our center of rotation. Okay? We said the image of A, right? A is our pre-image. Our image would be located at 2 and negative 2. Here's our A prime. B prime is located at 2, comma, negative 8, over 2, down 8, 1, 2, 3, 4, 5, 6, 7, and 8. Right? That's the location of B prime. C prime is located at 5 and negative 3. 1, oops, I'll do that. Right? 1, 2, 3, 4, 5. 1, 2, 3. 5, comma, negative 3. Right? There's our C prime. We get a collection of points, right, in a straight path. Right? We'll use red. We're going to go here. We're going to go here. And we're going to go here. So there's our image of triangle ABC after a 90 degree clockwise rotation. All right. Now, let's see, what's our next problem? Okay. Well, let's look and see if we can develop a rule. All right. A rule for that 90 degree clockwise rotation. Right. Point A was located at 2, comma, 2. A prime is located at 2, comma, negative 2. Alright, let's see about point B. Point B is located at 1, 2, 3, 4, 5, 6, 7, 8, comma, 2. B prime after a 90 degree clockwise rotation is located at 2, comma, negative 8. Point C is located at 1, 2, 3, 1, 2, 3, 4, 5, 3, comma, 5. and C prime was located at 5 comma negative 3. Okay, well, if we're trying to come up with a rule, x comma y, right, what do you notice about your x value and your y value? What you might notice is that we have an x value of 2, right, and an x value of 2, x value of 8, right? So our original y value is 2, our x value here is 2. Our original y value for B is 2, our new x value for B is 2. Our original y value for C is 5, our new x value for C is 5. So if we're looking at a rule, the first value in the ordered pair of the image is going to be, let's see, we have negative 2, we have 2, 2, and 5, and they correspond with the y values. So that whatever the y value was of our original ordered pair, that became the first value in the image. Our y value here was 2, our x value in the image is 2. Our y value for the pre-image is 2, the x value of our image is 2. Our y value of the pre-image is 5, our x value of our image is 5. And then if we're looking for the y value here, it winds up being the opposite of whatever the x value was. Our original or our pre-image x value is 2. Our image y value is the opposite of 2. Our pre-image x value is 8. Our y value image value is the opposite of 8. Our pre-image x value is 3. Our y value image value is the opposite of 3. So it would be the opposite of x. So that's the rule that we would use for a 90 degrees clockwise rotation. Right, clockwise rotation. Let's look and see what happens with a 180 degree rotation about the origin. Alright, so here's the same figure. Alright, 180 degree rotation. What's that going to look like? Well, 180 degree rotation would actually be 2 turns of our paper. So if I start here, that would be a 90 degree clockwise rotation, and then another 90 degrees would be a 180 degree rotation. Notice the location of our triangle. It's located in quadrant 1, 2, quadrant 3, right? Well, let's see. If I rotated 180 degrees the opposite direction, counterclockwise, right? There's 90 degrees, 180 degrees, right? I'm still located in quadrant 3. So whether we have a 180 degree clockwise or 180 degrees counterclockwise rotation, I wind up in the same location, right? Well, let's list our ordered pairs for our image. Okay? So our first ordered pair, let's call it A prime. A prime is going to be located at what? Negative 2, negative 2. So we have negative 2, comma, negative 2 for A prime. B prime is going to be located where? Well, we're negative what? 1, 2, 3, 4, 5, 6, 7, negative 8 in the x direction, negative 2 in the y direction. Our C prime location is located where? Negative 1, 2, 3, negative 1, 2, 3, 4, 5, negative 3, and negative 5. Right? So now that we have the coordinates of our image, I'm going to put this back. Right, let's rotate this back up and minimize this bit. Okay, and let's see, let's graph our image. So I start with negative 2 and negative 2, negative 2, negative 2. It's going to be A prime. B prime is located at negative 8, negative 1, negative 2, negative 3, negative 4, 5, 6, 7, 8, and negative 2. There's my B prime. And then my C prime is located at negative 3 and negative 5. Right, there's my C prime. I want to connect those points using a straight line. Keep it red. Alright, and that's going to be here. It's going to be here. And that's going to be here. Now let's talk about a rule for a 180-degree rotation, right? Whether it's clockwise or counterclockwise. The rule is going to be the same, right? Point A was located where? At 2, 2. A prime after a 180-degree rotation is -2 and -2. Let's look at B, location of point B. That was located at 8, 2. B prime is -8 and -2. Let's look at point C. That was located at 3 and 5. And C prime was located at -3 and -5. Right? And what do you guys notice if you're trying to write a rule? Right? X comma Y goes to, right? Looks like we have the opposite of our X value. Our pre-image X value is 2. Our image X value is the opposite of 2. Our pre-image X value is 8. The image X value is the opposite of 8. Our pre-image value is 3 for X. Our image is the opposite of 3. So we want the opposite of X. And look at our Y values. We go from 2 to the opposite of 2. 2 to the opposite of 2. 5 to the opposite of 5. Opposite Y. So that's a really easy rule to remember. Right? And if you remember our rule for reflections, right, we had the same rule if we reflected over the x-axis and y-axis, or a reflection of y followed by x. We had the same rule: opposite x, opposite y. Right, let's take a look at the rules in summation. A 90-degree clockwise rotation. Here's our rule: x and y go to y and opposite x. A 180-degree rotation: x and y go to opposite x and opposite y. And if we have a 270-degree rotation, right, these are all clockwise rotations that are shown, x and y go to opposite y and x. Now, one thing to remember, a 90-degree counterclockwise rotation would be the same as a 270-degree rotation. So let's write that. 270-degree rotation that's clockwise is the same as a 90-degree counterclockwise. Right, counterclockwise. And a 90-degree rotation clockwise would be the same as a 270-degree counterclockwise. Right, counterclockwise. Okay, so we can use those rules when we do our rotations, all right? Okay, let's keep that in mind. And I'm going to take those rules and let's see, all right, I'm going to copy them, click, and click, right, because we'll probably be using those rules over and over again. Right, send to the current page, and I'm just going to cut that, and then this way we can paste it where we need it. Okay, let's look at our next example. We want to rotate the trapezoid ABCD 90 degrees and 180 degrees about the origin. Let's assume it's clockwise rotation. Write the coordinates of A prime, B prime, C prime, D prime, and A double prime, B double prime, C double prime, D double prime. All right, let's go ahead and look at those rules. So I'm going to paste these here, right, because, oops, right, we would be using those rules, right, would be useful. Okay, so let's start with, oops, let's start with our 90 degrees clockwise rotation. So let's do our 90 degree first, right? A prime is going to be located where? Well, first we need the locations of A, B, C, and D. So let's start with that. Point A is located at where? 1 and 3. Point B is located where? 2, 4, 6, 7, and 3. Point C is located 1, 2, 3, 4, 5, and 1. And point D is located at 3 and 1. Right, so we're going to use those original locations and our rules to generate our coordinates for our images. So 90 degree clockwise rotation, we're going to use the following rule here, right? That's our 90 degree rotation rule. So I need y followed by opposite x. So if I take a look at point A, my y value is 3, followed by the opposite of x. The opposite of 1 would be -1. B prime, I need the y value, which would be 3, and then I need the opposite of x, negative 7. C prime, I need, where is it, the y value, which is 1, and then the opposite of the x value, which would be negative 5, and then we have d prime. For d prime, we need what? The y value, which is 1, and then the opposite of x, which would be negative 3. So those would be the values for your 90-degree clockwise rotation, and then your 180-degree rotation. We'll do in a different color, right? The 180-degree rotation, right? We have A prime, B prime, C prime, D prime. Okay. All right. Let's list our ordered pairs that way. A 180-degree rotation, we need the opposite of x and the opposite of y. Opposite of x would be negative 1. Opposite of y would be negative 3. Right? These are B double primes, C double primes, right? The second image, so I need the double prime there. B would be opposite at x, opposite y, negative 7, negative 3. Point C double prime would be opposite x, opposite y, negative 5 and negative 1. And then D double prime would be opposite x, opposite y, negative 3, and negative 1. Now, if you want, you can draw your figures, even though it doesn't say to draw them, but it's always good to draw them just to see, right? We know that 90-degree rotation should take our figure, which is located in quadrant 1, should bring it down here to quadrant 4. And then 180-degree rotation would bring our figure over here into quadrant 3. Right? So let's just graph these ordered pairs so that we can see them pretty clearly. So A double prime is 3, negative 1, right? There's my A double prime. 3 and negative 7 over 3. 1, 2, 3, 4, 5, 6. Right, here's my 3, negative 7. That's my B double prime. My C double prime, or my C prime, oops, not double primes. Let's be careful there, Palada. Right, they're primes, not double primes. Right, we don't want to rush, make mistakes when we rush. They're primes. It's our first image. We have 1 and negative 5, right? 1 down 5. That's going to be C prime. And then 1 and negative 3. That's my D prime. Let's connect those points in a straight path. Right, we're here. Right, we're here. We're here. Oh, be a little neater. And we are here. Right, let's try to be a little neater with those points. Right, and move that up. Should be like that. And I think this point is off a little bit too. Be careful. Alright, so there's our first image. And let's draw our second image. Do that in green. We have negative 1 and negative 3. Negative 1, negative 3. That's A double prime. Then we have negative 7 and negative 3. 2, 4, 6, 7. Down 3. That's my B double prime. Then we have C double prime. Negative 5, negative 1. Here's negative 5, negative 1. My C double prime. Then we have negative 3, negative 1. Right, negative 3, negative 1. My D double prime. Connect those points in a straight path. Right, make those green. Right, so we're going to be here, 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 and here. Right, so we do notice that we go from quadrant 1 to quadrant 4, quadrant 1, quadrant 3 with the 180-degree rotation, and 90-degree clockwise we go from quadrant 1 to quadrant 4. Alright, okay, 90-degree clockwise about the origin. Right, we can use our rule to do that. Right, so I'm going to paste my rule here. Right, paste the rule, oops. Right, we paste the rule. Undo that. Undo that. Killing me here. Right, let's bring that down here. So this is a 90-degree clockwise rotation. I guess I can leave that up there then. First we need our ordered pairs. Point A is located where? That's 1, 0. Right, that's 1, 0 for point A. Point B is located at 2, 4, 6, 0. And point C is located at 4, 2, 4, 5. 4, 5. Our rule for a 90-degree rotation says we need y and opposite x. So a prime would be located where? That's 0, negative 1, our y value, and then the opposite of the x value. B prime would be located at y opposite x, 0, negative 6, and then C prime is going to be located at y opposite x, 5, negative 4. Graph those ordered pairs, 0, comma, negative 1, A prime, 0, negative 6, 2, 4, 6. So my B prime and my C prime is at 5, 2, 4, 5, and negative 4. 5 and negative 4. There is my, let's see, what is that? C prime. C prime. Connect those points. For here, here, and here. Alright. What's our next question? Triangle ABC has vertices at 0, 4, 0, negative 2, and 2, 0. The triangle is reflected over the x-axis, then the image is rotated counterclockwise about the origin. What are the coordinates? Alright, so we're going to have to use two rules to get our ordered pairs. Alright, so let's start. If we're reflecting over the x-axis, we know the x value stays the same, y value becomes its opposite. So, oops. Let's do an x-axis reflection. Right, so the x reflection, right? X reflection, x comma y goes to. X value stays the same, y value becomes its opposite. So that's x opposite y. And then for the 180 degree counterclockwise rotation about the origin, right, that's going to be 180 degree rotation. X comma y goes to, right, opposite x, opposite y. Okay, so let's see what that's going to look like. Point A, right? A is located at 0, 4, so let's go with A prime. Right, we have to use the first rule, then the second rule. First rule, 0, 4. X opposite y would be 0, negative 4. But then I need opposite x, opposite y. So 0, negative 4, right, would be 0, 4. Right, opposite x, opposite y. Right, and let's double check that. X, opposite y would be 0, and then negative 4. Right, and then I need the opposite of that and the opposite of that. So that would be correct for our image. B prime. We have 0, negative 2, so the x-axis reflection would be x opposite y. That'd be 0, 2. But then I need opposite that, that'd be 0, negative 2. Starting to see something interesting. And then the last ordered pair, let's see, is 2, 0. 2, 0, x value stays the same. Y value becomes its opposite, 2, 0. So let's see, C prime would then be opposite x, opposite y. That would be negative 2 and 0. Right? So that point does change. So let's see what that would look like then. Triangle ABC. Okay, what are the coordinates of the final image? Right? These would be the coordinates of the final image. We have to apply each of these two rules, right? Each of those two rules to generate first the x-axis reflection, and these would be the coordinates of the x-axis reflection, where the x value stays the same, y value becomes its opposite, right? X value stays the same, y value becomes its opposite, x stays the same, y becomes its opposite. Then we have to do opposite x, opposite y, right? Opposite x, opposite y, that would be right. Opposite x, opposite y, right? So they would be our coordinates. All right, so you're going to have to practice a little bit, play around with these rules, okay? Let's see, we'll do one more. This one is another multiple transformation. We have, let's see, a triangle. It has vertices. We want a translation and then a reflection over the y-axis. So we're putting more than one transformation together, right, with these last couple of problems. Well, let's start. If we have first a translation of 4 units right and 2 units down, all right, so that first one, right, that's going to be x comma y goes to translation of 4 units right, it's going to be x plus 4, and then 2 units down, that's y minus 2, right? That's the translation, and then the reflection, x comma y, goes to the reflection over the y-axis means that y value stays the same, x value becomes its opposite. So that's going to be opposite x comma y. All right. So let's use those two rules to generate the image points. Find the vertices of its image after a translation 4 units right, 2 units down, then a reflection over the y-axis. All right. Let's see what we got. Let's start with our first order pair. We're at -3, and we add 4. We're going to be at +1. I'm at +1. I want the opposite of +1, so that's going to be -1. So f prime, the value would be -1 for x. Let's look at our y value. 7 take away 2 is 5, and then the y value stays the same. So that's going to be 5. G prime. Let's start. -1 plus 4 would be +3, but then I want the opposite of that. It's going to be -3. Let's see. 5 minus 2 is 3, and the y value stays the same. That would be 3. And then we're looking at point H. Right, so H prime, we have +4 to -2. That's going to be +2, but I want the opposite of that. That's going to be -2 when we reflect it. Comma, I want to take 2 away from 2, that's 0, and the y value stays the same, 0. So here are the ordered pairs using the two rules. If we have the image is translated 4 units right and 2 units down, then we use the rule for our reflection. Okay? All right, now you guys get a sense of what it looks like to do more than one transformation. All right, let's try one more. We have the vertices of a rectangle this time. We're rotating it 90 degrees clockwise about the origin, and then we're reflecting it in the y-axis. What are the coordinates of the image? So we're going to keep using those rules. All right, so let me paste my rules here for the 90 degree rotation, clockwise rotation about the origin. So my first rule for the 90 degree rotation, right, that's going to be x comma y goes to, that's going to be y opposite x, and then we are doing what? Reflecting in the y-axis. So the reflection in the y-axis, x comma y, goes to reflection in the y value means that it's going to be the x value becomes its opposite, y value stays the same. Okay, so let's apply these rules to each one of these ordered pairs. So our image, A prime, let's start with the x value. All right, so the first value in the ordered pair is going to be the y value. So that's going to be -3, but then I want the opposite of that. The opposite of -3 would be 3. Then I want the opposite of the x value. The opposite of -3 is 3, right? 3, and then that value is going to stay the same. So that's going to be 3. All right, let's look at B prime. B prime. The first rule, right, the first order pair, it's going to be the y value, so that's -3, right? But then I want the opposite of that. The opposite of -3 would be 3, comma. All right, let's look at the second value is the opposite of x. The opposite of 1 is -1, and that value stays the same, right? Whatever the y value was, right, that's going to stay the same. Okay, and then we have what? C prime. For C prime, we have 1 and -5. So for the 90 degree rotation, the y value is going to be first. It's going to be -5. Oops. But then I want the opposite of -5, or I want the opposite of that. That's going to be 5, comma. Then we need, let's see, we're going to have the opposite of whatever x is. So that's going to be -1, and that value stays the same. All right. Should be -1, and then D, what is it? D prime. D prime. All right, where's my D? I need the y value is going to be first, but then I want the opposite of that, so it would be -5, and the opposite of -5 would be 5, comma. Then we have, let's see, the opposite of the x value, which would be 3, and that value stays the same, 3. So they would be the order pairs for the 90-degree rotation about the origin, clockwise, and then reflected in the y-axis. Alright, so those are just a few examples of some of the transformations that we can play around with. Alright, you guys do your best with that. Alright.